Okay, so now we're going to convert from rectangular coordinates to polar coordinates. So that means this is x and this is y. Now you might be a little concerned and you might say, well, how will I know if they give me an ordered pair? How will I know if it's rectangular or polar? They're either going to tell you or you'll know by context. So right now it's a little tricky because we're going between the two. So they tell us, though, what we have. Okay, so r squared equals x squared plus y squared. Well, we know x is 3 and y is 3. Oops. And so we get what? 9 plus 9. So r equals the plus or minus the square root of 18. Okay? Now, let's think a little bit about that. We know it's going to be positive because these are positive. So you're going to be, it kind of depends on where we're rotating. But we'll come back to the rotating. Well, we'll do the rotating right now, and then I'll explain it. Okay. Tangent theta is going to equal 3 over 3. I'm sorry, I didn't write the formula. It was tangent theta equals y over x. Okay, so 3 over 3 is 1. And then we know where tangent is 1. It's going to be, now remember, you're going to think, okay, where is tangent 1? Well, you could say, well, it might be in the first quadrant or the third quadrant. But look at the x and y they gave you. That's first quadrant, right? So we've got to be in the first quadrant. And this is going to be pi over 4 then. Theta is going to be pi over 4. And then the radius is going to be, well, the square root is going to be the square root of 18. It's going to be the positive one to keep you in the first quadrant. But you're going to have to simplify that. So that's 3 times the square root of 2. And so you're going to write the ordered pair in polar coordinates, 3 square root 2, comma, pi over 4. Okay. And yeah, there are other forms that would get you that same point. But like you could go third quadrant, but then go negative with the negative radius. But we'll just go with the positive here.